Hello, everyone, and welcome. Today I'm excited to walk you through a project very close to my heart, our 2D cozy farming game. This isn't just any game, it's designed to be a relaxing, engaging, and stress relieving experience for players of all ages. Our vision for the game is simple: to create a charming 2D farming simulation. Imagine cultivating crops, personalizing your own farm, interacting with quirky non player characters, and completing fun tasks. It's all about providing a gentle, enjoyable gaming experience. Let's quickly highlight some of the core features you can expect. You'll be able to choose your character, either a gnome or fairy. You'll navigate a delightful forest environment. A friendly guide NPC will be there to offer tips. The heart of the game is the core farming loop: planting, watering, and harvesting various vegetations. You'll have extensive options for farming customization. And of course, you'll sell your harvest to earn in-game currency. We've also included a task system and minigames for a variety and progression, alongside an achievement system to track your accomplishments. Technically, we're building this on the Godot engine using its native GDScript language, and it's designed for desktop platforms like Windows, macOS, and Linux. Now let's talk about how we define what this game needs to do. This is where our software requirement specification, or SRS, comes in. The SRS is our foundational document. It's the formal agreement that outlines all the functional and non-functional requirements. Think of it as a blueprint for what we're building. It starts with a clear introduction, defining the purpose and scope of the game. Then we move into an overall description, giving a broad view of the product, its target users, and environment it operates in, including any design constraints. The most crucial part is Section 3, Specific Requirements. Here, we break down every single player interaction into functional requirements, or use cases. For example, use case number 1, character selection, details exactly how a player chooses their character step by step. We have 13 such use cases, each with precondition, postcondition, and detailed scenarios. Equally important are the non-functional requirements. These define the qualities of the game. For instance, NFR specifies that the game must maintain a minimum of 30 to 60 frames per second, and NFR dedicates the loading times shouldn't exceed 10 seconds. We also cover usability, maintainability, portability, reliability, and basic accessibility. Finally, the SRS covers external interface requirements, how the game interacts with the user, hardware, and other software, and other requirements like legal consideration and plan for future expansion. Once we know what we need to build, the software design document, or SDD, tells us how we're going to build it. This document is our detailed blueprint for implementation, covering the system's architecture, component designs, and data structures. The SDD starts similarly with the introduction. Then we dive into system architecture. This is where we define the high-level structure of our game. As you can see in our high-level component diagram, we've organized our game into logical packages, declining with the UI layer, the game core housing game logic, farm system, inventory system, task manager, NPC system, and minigame engine, and finally, persistence with the data manager. This diagram clearly shows how these major parts interact. Below this, our architectural patterns include a component-based architecture, leveraging Godot's node system, a conceptual layered architecture, the use of singleton for global managers, and an event-driven architecture primarily through Godot's signal system for decoupled communication. Moving to detailed design, we break down the internal structure of our core classes. Our class diagram
For data
illustrates
design,
key entities like player, inventory, farm system, plot, crop, task manager, and task, showing their attributes, methods, and relationships. This gives our developers a clear object-oriented view. For data design, we define how our game's information is structured and stored. Our entity relationship diagram, or ER diagram, visually represents the relationship between crucial data entities like player, item, inventory, plot, crop, task, and player task. This ensures our save game structure is robust and well organized. We also detail the structure of our save file, which is JSON format reflecting this normalized model, and explain the data flow between components, showing how information moves dynamically through the system during gameplay, like when a player plants a crop. Speaking of which, our sequence diagram for planting a crop illustrates this dynamic flow in detail. You can see the exact order of messages between the player, actor, the UI, the player class, inventory, farm system, plot, crop, and even the achievement manager, from clicking a seed to it appearing on the plot and potentially unlocking an achievement. The SDD also covers design constraints like performance targets and memory usage, security and safety considerations for a safe game integrity and important design decision made during the process. Finally, to ensure our game is reliable and meets all expectations, we have the Software Test Document, or STD. This document is our roadmap for quality assurance. The STD starts with the test plan, outlining the scope, objective, and specific features we'll be testing, directly linked back to our SRS use cases and non-functional requirement. It also clearly states what we won't be testing, like multiplayer functionality, in this phase. Our test approach is comprehensive, involving unit testing for individual functions, integration testing for how modules work together, system testing for the entire game, and ultimately acceptance testing with stakeholders. We use both black box, testing for a user's perspective, and white box, testing internal code. Along with regression testing to catch any new bugs, we define clear pass-fail criteria and rules for when we need to suspend and resume testing. The test design specification section contains our detailed test cases. For example, how we verify planting a carrot seed step by step, including preconditions and expected results. We also outline general test procedures for setup, execution, and defect reporting. Finally, the test execution report, which gets populated during actual testing, will contain the test result, a defect report, any bugs found, and a traceability matrix to ensure every requirement from the SRS is covered by a test case. So, to summarize our project's journey so far, our SRS clearly defines what we need to build, our SDD provides the detailed blueprint for how we'll build it, and our STD ensures how we'll verify its quality and correctness. These three documents form a robust framework for our development process. Looking ahead, our next steps are clear. Implementation will now develop the game based directly on the STD's detailed design. Rigorous testing will execute tests meticulously following the STD, logging all results and defects. Iterative development will continuously address identified bugs, refine features, and conduct further testing cycles until we achieve a polished product. Overall, our goal remains to deliver high quality, reliable, and truly enjoyable 2D cozy farming game that meets its core objectives and delights its players. Thank you for your time.